I just cannot get this Ethernet port to fit in this USB-C adapter. It's like they're not the same standard. By the time we're done here, we will understand the various flavors of the Spanning Tree Protocol standard. I've got to say, if that doesn't make you laugh, it makes me laugh, and that makes me happy. So Spanning Tree has been around for a very, very long time. When Spanning Tree first came out, it came out as what's known nowadays as Common Spanning Tree. They didn't call it that back then because they didn't know any better. It's just, hey, we've got this problem. We've got these switches. We know they need to be redundant, but if we do that, it blows up every single time as soon as the first broadcast comes in. So let's create something called Spanning Tree Protocol. And by the way, the original standard is actually 802.1d. There's very few standards that you should know off the top of your head. That's, I don't know. It's probably one of them. Probably not as important nowadays because there's not as much common spanning tree. It's more of like a rite of passage. Like, yo, you should know that. So Common Spanning Tree did exactly what I mentioned in the last video. It detected loops in the network, disabled the link based on where the root bridge was placed, and that was the formula I talked about in the previous video. The challenge with it is it was created in 1993. I mean, this is the time of existence where we were just happy that the network was online. If there was a failure and it failed over in less than a minute, we were pretty happy about that whole thing. Well, that was pretty much about how long it took. It was somewhere between 30 and 50 seconds because, again, that was in an era where technology wasn't as on the minute as it is right now. It's funny. My kids are in the other room. I just went and checked on them, and they are watching Disney WALL-E. Have you ever seen that movie where it's looking at the future and all people do is like they're in this spaceship. The Earth got blown up because we were just consumeristic, and they shot off into space, and all they do is just look at screens all day, and they float around their little chairs. So anyway, that wasn't the era in 1993. That's where we're headed because Rapid Spanning Tree was developed. I'll come back to the per VLAN. Don't worry. Rapid Spanning Tree was developed to try and overcome that. So Rapid Spanning Tree took our 30 to 50-second failover timer, meaning, and I just want to make sure you guys understand this. Spanning Tree blocks links, right? That's what. Nope. Took that link down altogether. It blocks links. So it's like, okay, there's redundancy. We don't need this one. But all of a sudden, oh no, somebody trips. This cable gets unplugged. It's going to be about, if you're running original Spanning Tree, 30 to 50 seconds before this link goes active, right? Rapid Spanning Tree, 2 seconds. Now, in today's network standards, that's still too long. And that's why in really high-end network, they've left Spanning Tree behind altogether and gone with layer 3 connections using, you get sub-second failover. And now I know you might be like, why? Well, because in our networks of today, think about eBay, right? How many auctions on eBay are ending every single second, right? And if something were to fail and people are like, refresh, or subsec, that failover could cause a database drift, and now everything's out of sorts for a little while. Airline schedules. We work nowadays on this sub-second interval, so we have to be able to fail over that fast. So Rapid Spanning Tree, I would say, is good for most networks. And I know many of you are like, well, I'd be happy with 2 seconds. So would I, but I don't work in a data center. I don't work on eBay or airlines. So Rapid Spanning Tree helps in a major way, taking this down. But 2 seconds, just to say it, is not acceptable for most network standards. So Cisco, in the meanwhile, notice I have standard, right? And I haven't even gotten to this one at the bottom. Cisco, as each standard was released, produced their own proprietary version of that standard. What they did was they said, you know what? I don't want to have a common spanning tree. I want to have a spanning tree that works on every VLAN, thus calling it per VLAN spanning tree. This actually is a pretty big deal because normally with common spanning tree, and by the way, common spanning tree encompasses this version and this version. They both follow the same scheme. What happens is, let's just say you've got 5 VLANs. VLAN 10, 20, 30, 40, and 50, right? Those VLANs exist. So you've got those on all your switches. Well, what spanning tree does is exactly what I showed you it does. It looks around, it's like, hey, we're redundant, so bam, I'm going to block that link so we don't have any loops, and all the traffic will use these links to reach each other. And so this is essentially disabled until it's needed. Well, that's kind of lame, because now you've got a link that's completely unused. I mean, it's idle, whereas this might be reaching its capacity. I mean, so you add a second link right there. You add a second link right there. What happens? Spanning tree is like, bam, bam. That's a loop. Block it. Now, there is the technology I'll talk about a little bit later called Ether channel. That's Cisco's word for it. Most other vendors call it lag ports, link aggregation, where you can bundle those guys together into a single link, and spanning tree sees them that way. But we're not talking about that right now. I'm just talking just link redundancy. Spanning tree always disables it. So Cisco said, what if we allowed you, with our per VLAN spanning tree or per VLAN rapid spanning tree, they came out with both versions, we allowed you, if you buy Cisco switches, to separate the root bridge per VLAN. So I could say, I want this guy to be the root bridge for VLANs, let's just say 10, 20, and 30. And I want this guy to be the root bridge for VLAN 40 and 50. So, okay, you're like, what's that do? Well, remember, where the root bridge is how it figures out what links to block. So watch this. It actually runs multiple spanning tree calculations per VLAN spanning tree calculations. It's going to say, okay, for VLAN 10, this guy's the root bridge. So that's the best way. Okay, we'll disable that link, but for VLAN 10, disabled, right? Okay, VLAN 20, that's the root bridge. So, okay, VLAN 20. This is disabled, right? You see where I'm going with this, right? So this link is disabled for VLAN 10, 20, and 30, right? It doesn't use it. It always goes this way. But then it runs the root calculation for VLAN 40. And it goes, okay, well, this way is the best way. And from this switch, this way is the best way to get to that root bridge. So now that link is disabled for VLAN 40. And then runs the same thing for VLAN 50. Figures out it's like, and 50. So this path gets used for VLAN 40 and 50, and this path gets used for VLAN 10, 20, and 30. So in a way, per VLAN spanning tree lets you do a little load balancing. Lets you take links that common spanning tree or common rapid spanning tree, which is the other version, would normally disable for everybody. And Cisco's like, no. You can use these on a per VLAN basis. Well, as most good ideas do, the industry eventually is like, I kind of like that idea. So we're going to create something that's called multiple spanning tree. What multiple spanning tree is it's rapid spanning tree plus the ability to group VLANs. Now, it's not as simple as per VLAN spanning tree. Per VLAN spanning tree, you're like, that's the root for that, that's the root for that, and it just kind of does its thing. With multiple spanning tree, you have to be like, okay, I'm going to put VLAN 10, 20, 30 into a group. Boom. I'm going to put VLAN, so it's the same thing, it's just more configuration. But I will say, multiple spanning tree has one benefit. The more VLANs that you add, I pointed at the wrong thing. More VLANs you add with per VLAN rapid and per VLAN spanning tree, the more overhead it takes. Because you actually run one instance of spanning tree per VLAN. So remember I said this guy is the root for 10, 20, and 30. So it's going to run spanning tree protocol for VLAN 10 and spanning tree protocol for VLAN 20. It's like, I don't know. It's like inefficient. And so if I'm like, I want to run Windows to run Microsoft Word, and then I'm going to boot up another version of Windows to run Microsoft Excel, and then boot up another, you get what I mean, right? Like you're making copies of processes to do that. Whereas multiple spanning tree allows you to say, I want 10, 20, and 30 to be in a group, and then it runs one instance of spanning tree for all three of those. So if you're a Linux person, you know processes. If you're not, think of it like versions of Windows, right? So multiple spanning tree, way more efficient and probably preferred in large networks. Okay, so that's it. That's the spanning tree standards. You now understand those various flavors. Now, which version, I should mention before we go on and get into some more of the config side of things, the version of spanning tree that you're using is iOS dependent. The older switches will run the original common spanning tree right out of the box, 802.11 or 11, I'm thinking wireless, 802.3. Oh no, hang on. 802.1D. That's terrible. I just said that you should learn that, and then I'm like, I don't remember. I remember it. It's just it's late. My kids are watching Wall-E. I'm gonna go watch it with them. So anyway, these guys are running the original common spanning tree, or a lot of times the per VLAN spanning tree out of the box. So you'll have to tweak it. Whereas the newer iOS versions and newer switches will run rapid spanning tree out of the box. Well, I hope this has been informative for you, and I'd like to thank you for viewing.